Hello, everyone. Welcome to this talk about Angular. Today the goal is to go through all the major changes from Angular since almost Angular 14 up to 17 and maybe a bit further than that. But before starting, I'm curious, how many of you is using a version newer than Angular 14 here? Okay. How many of you is using something between 14 and 10? Not that much. Is there that much people that's using a version then older than 10? Okay, that's not much. For the other, sorry if you're lost. We're going to speak about Angular here. My name is Magnette. I'm a senior developer for a Belgian consultancy company called Onirix. I'm also the pro dad of a 2 years old, and you might wonder why I'm talking about that, and you probably will understand why we'll see when you will see my demos. Besides that, you can find me on social network. There's the names and tags there. And let's get it started. Before going to all the newest stuff of Angular, I think it's interesting to go back to Angular 14 and 15. Because Angular 14 and 15 introduced quite a lot of changes that paved the way through what we are going to see next. In my job, I do frequently interviews, and when you ask people, okay, in Angular, what are the most important stuff you have? Most of people answer components, services, maybe a resolver or guards. But before Angular 14, you couldn't build an application without modules. You needed modules everywhere to build your application, to bootstrap your application, to do the routing. You have module everywhere. And that was a big complication for newcomers because they need to learn about module even before learning about components. And another thing is when you have a large application, people try to use module to compartmentate their application, to make small things. And at some point, they create a command modules and say, let's bring in the command modules, everything I need almost everywhere. So you pick up some translation, maybe some Angular material, and you end up creating a big module, that big command module that is imported everywhere. And so all your modules are becoming bigger and bigger every time you increase what's in the command module. And that became quite an issue. So people try to find a way to go around that. And to do that, there was a simple solution. They say, let's make one component and one module. For each component, I have a module. Basically, it creates one more file for each component. But that way, I don't bring everything with me, I just take what I really need. And because we are in computer science, we like to name everything we have. And we create a beautiful name for that. It's single component Angular module. And that's quite long. So we find a really nice acronym, SCAM. I don't want to tell you how many times when you are in a meeting with a client and you talk about SCAM, they get really scared. And you're just talking about Angular component, basically. But basically, this change, this logic, paved the way for what came with Angular 14 in preview and was totally released with Angular 15, standalone components. The idea behind this standalone component is to say, we don't need modules. My components can live by themselves and import what they need, and what they don't need, they don't import. So they reduce and remove every module in your application. You don't need to do it, but that's the goal with a standalone component. But if you think about it, when you remove modules, there is quite some impact. The first one is for the routing. If you look in your application, and you look how you route things, most of the time you have a routing module. So one module already on your way. The second thing, you can navigate to components, but not standalone components. So that's another change we had to do. You can lazy load modules and routes and components. They had to change that also because no more modules, no more routing modules, and you need to load all those things. So that's already a big change. Another part was bootstrapping. How many of you open the main TS in your Angular application frequently? Yeah, nobody. And basically, that's where the bootstrapping is done. But you had to change it because the bootstrapping was based on modules. So we had to change all those things just to have standalone components. But enough talk. Let's see what it looks like. So just so you know why I have a 2-year-old, I have dinosaurs everywhere. That's why the shirt. She loves dinosaurs. And that's going to be my demo today. So I will try to have this. I have still an app component with an app module just here. And I'm going to try to convert it manually to standalone. The first step is quite simple, is to say, OK, now I want my component to be standalone. Easy enough. But now I need to import all my dependency. So if you have a nice IDE, it's easy as Alt-Enter or something like that. But basically, my app won't run because my app modules tries to declare a component, but doesn't make sense. It's a standalone component. It doesn't need this declaration. So you need to remove that. But how am I supposed to say, where is my component? Basically, if I had routing, I could simply import my app component and use it. But because I want to go all the way and show you how you can bootstrap your application, that's why I changed the app module and the app component, you're going to need to edit the main TS file. This part is the old way to do it. The new way, you use bootstrap application. You provide your component that you want to use. Of course, you still need to catch the error. That doesn't change. But you need still to give him routing and some other module you might need. And to do that, you can provide an object to configure everything and provide something, so providers, and you can give him an array. And you can still use provider like you used to do, but for most of modules now, there is a function for you to import. So you can provide a router, and you need to provide some routes. I will do that in a moment. You can also provide HTTP client, because we do remote request. You could provide some animations, and so on and so forth. You can re-import everything you need there. So, as I said, I need my routes. And I say no more modules, so no more routing modules. And what it means, your routes are no more required to have a module now. You can simply, and I wouldn't recommend putting here in your main TS, but put it in your file name, main routes or ARP routes or something like that. For the demo, I will go a bit faster in that. I can provide my routes directly here. And now I can basically remove those two files and say, I don't care. I might still have imports in here that I don't need anymore. And basically, my app is back there. So I've changed everything and it's still working. And the part that you didn't see till now is that if I take another component that I'm using, it's already a standalone. So you don't need to migrate all your application to standalone to use standalone. You can mix and match both of them, and it's still working. You can have modules and have on the other side standalone components. It will work. And if you have to start changing to standalone components, the best place to start is in your command module, because that's the thing that's basically import everywhere and where you have a lot of stuff that you might not need everywhere. So don't start with the app module. Start with the command module. That's where you will see the most impactful change for your application in terms of performance and things like that. But of course, we are developers, and I don't imagine someone with an Angular application with 2,000 components doing that by hand. And Angular is agreeing basically with me, because they introduced a little command in the CLI to do migration. To do the migration, you can run this command, and it's basically kind of a wizard. The first thing it's going to ask you is, what do you want to do? Convert all your component directives and pipes in Standalone, remove unnecessary class, and bootstrap. Basically, you will do each of them one at a time. So you will start by, okay, I want to convert my components, and it will tell you, do you want to change every component or just some part? And again, if you have a big application, do it by small pieces. Don't do all the application at once. That's the best way to crash everything and having pain for days and days. And when you say, okay, I want to migrate this part of my application, it will run. Then, when it's done, you can remove all the ng module. Basically, what I did, removing those two files, it will do it and go through your application saying, okay, all those modules I don't need anymore, I'm going to remove it. And when you reach the point where, okay, you migrate all your application, or at least the one that I need for doing the bootstrapping, you can do it just by running the last command, and the last command basically will do the change I did in the main TS file. And that way, you can migrate easily your Angular application to Standalone without needing to go in every file and change everything. That was one of the biggest changes we got. But we changed some other things. Among them, guards. And for most of you, you know guards from can activate, can deactivate, can load, and things like that. There was one special case that was never covered, basically. If for some reason you wanted to have two routes on the same path, and you might wonder, why do I want that? A simple use case is if you have an admin user and just a classical user, and you want your admin that can copy-paste the URL to the profile of the user, you can do it with something like that, because he copies his URL, and based on his permission, it will land on the right page and not the admin page with something saying you cannot go there, you're not authorized. That's way nicer. But if you do that without any guard, basically you always end up on the first line, just the first one. So we create a new guard called canMatch, and basically this guard is just a check to say, can I go there or not? And if I cannot, I will fall back on the next route matching this path. And basically you can expect that the canMatch guard looks like a usual guard with a function that you need to implement. And if you look closely to the signature here, basically you can do everything you can do with a canActivate. So the canMatch, when it was introduced, made canActivate deprecated, basically. But for the keen eyes among you, you might have noticed that in my code, I have already something that is trite. My IDE is saying me, that's deprecated. And basically, they introduced canMatch in version 14, and 15, they deprecated it. That looks strange. And basically, what they say is, if you look at my class here, that's a simple one, but what's important in it? Basically, just those 3 lines. So I have 70% of my code that's boilerplate. I don't really need it. It's just there to do some big stuff, to declare a class and things like that. And it's basically the same if you take a resolver. So the idea came, why not a simple function? It's a simple function in the end. But if I go back there, I still have an injection here. I inject something. If I have a function, I cannot inject that. And basically, we've solved this problem by introducing a new function called Inject. And this Inject function can be used at loft space. It allows you to initialize a field. You can use a field and do inject a dependency. You can use it in a constructor. You can use it in a function, but there is one condition to use it in a function. it needs to be called either from a constructor or from a field. If it's not in those cases, you need the fourth line on my slide. You need to use run in injection context. And that way you can use the context injection. But I would not recommend using that except if you really need to, because it makes everything more complicated. You don't know where you inject stuff, you don't know why or things like that, and you can quickly get lost with your injection. And for the Java developer, and I think there is most of that here, that's something we can understand. If you use Spring, you either inject from the constructor or using auto-wired or something. You don't try to inject in the middle of your class. Doesn't make a lot of sense. So I will try to just show you what I explained here. So I have created a route, if I can find it. Yeah, and I typed too much. So I've basically created the case I showed you. I have two paths on ID. And the idea is when I click on one of them, I could have different interface. So for the purpose of the demo, I will just do some A/B testing, so randomly display one or the other. So I will create a new guard. I'm using this, not the dependency, the schematics. And I can create a guard. I will call it A/B testing. And will ask me, what do you want to do? Can activate child, can deactivate, or can match? So I will just say, I don't want can activate, I want can match. And basically create me the guard. And as we say, what we see, so it's a simple function. You just need to match the can match function. And I can basically return a Boolean if I want. So if I do that and I go back to my root, I can now say, okay, I have a can match, and it's an A/B testing guard. But if I just return true, there is no real interest in that. So if I go back there, I can now use my inject and inject a service, for instance, and use something on it to say, okay, can I go there or not? So like I said, this function is just a random. So from one time or another, I will land on another page. So here I land on another page. If I refresh, I can go back on the previous one. That's for the guard. But as I say, I can do that for the resolver too. So for this one, I will try to display a resolver. And I want to say, okay, I will have dino data, and the goal is just load the dinosaur before landing on the page. And I could basically do it just in line like this with a simple function. I will need something because I need to have the ID to load, so I can just get the root here, that is an activated root snapshot, and I can get then call the root, call the param map, do a get and say I want the ID. Ideally, I want that to be a number. So I will parse it as an int. And it won't be happy because it's a string, and it might be null also. So for the demo, I will just say 1 if it's not properly initialized. I will store it. Not the best variable name here. And then I can basically say return, and again call my service just using the inject function. And Copilot doesn't really know my function, but here, and it will basically load the data. And so now I have the proper data displayed in the other page. But if I look at this piece of code just here, and I go into the other component here, it kind of looks similar. All this part is done basically the same way. I'm repeating myself. That's not great. And basically, because I have the inject function now, I could simply say, what if I create a function that allows me to get number params, for instance? Oh. Basically, I will take a key, say, okay, I want this specific parameter. I will inject my activity truth, and that's not going to be a snapshot. I will take the snapshot instead, but just to say, yeah, and that's the type, so are you not happy? I think it. Yeah, it should be snapshot, right? And then I can write my function. And basically, my function could be this. And I can simply do return of this. And now I can use it almost everywhere I want. I don't need to duplicate any code. There is just one little thing. Because here I'm in a root, and the root doesn't have exactly the same context in injection, I cannot use the one I inject directly here. So I will provide the one I got here. But I could now do just get number params, saying I want ID, and provide, apparently my ID doesn't like me today, the root, and I don't need that anymore. And the nice part now, I can go in my other component and say, I don't need all this, but I can already do here, okay, I want to get my number param saying ID. I don't need this injection anymore. And basically, I remove a lot of code, and it's still working. There is less code. It's easier to maintain because you write it only once. That's way better. And that's all the whole point of this, those functions with the inject. You can now extract some code that you repeat a lot of times in a simple function that you can use everywhere. And just avoiding doing those basically inheritance everywhere just because I want to don't repeat myself. Because inheritance is not there to just don't repeat yourself. It's supposed to have some meaning. I'm not supposed to put cats and dogs in the same bag just to say, okay, I have the same way to give them food or just to create them. I'm supposed to because they have something in common in the behavior. And that's not behavior, that's just injection and getting the data. So that's it for the guard part. And from that, we can go to Angular 16. And Angular 16 introduced a lot of new features, again, to simplify your all work as developer. The first part is on the input. How many of you create everyday components with inputs and need to handle the case where this input is not required? Yeah. And because we have no way to say, oh, this input is required or not, and basically if you don't really read properly the doc, or you don't know the doc, or there is no doc, you're going to try to use a component. There is nothing telling you, oh, this input is required. So you try it, you run it, and then you have the error. It would be nice to know before running it. And they introduced those required type. Now you can say my input is required or not. That way, at compile time, you know, okay, there is an issue. You don't need to wait for runtime for some reasons. That's way better, especially if you use some components from someone else and it's deliver a new version and you don't know if anything changed, it will break your build. You will not go through production without knowing it. Another thing is, as I just displayed, we have resolver, we have parameters and things like that, but we still need to get them and put it in our components, and we repeat ourselves again. So they allowed us to now automatically map those data into our component using input. And we will see how to do that in a moment. And the last thing, sometimes you get an input and you need to transfer the data. If I take the example I got just previously, I got the parameter and it's a string, but I want a number, I need to transform it. So they provide us now a way to transform those data. So let's try it. To activate this feature, you need to basically change something in your bootstrapping. When you use a provide route, you can provide another argument called with component input binding. And what it does is it will allow you to automatically bind the data from your query params, your params, or even your resolver data, and try to automatically binding it based on the name you give. So if I take one of my components here, I have here something where I go into activated route, snapshot, get the data from my resolver. Now what I can do is just put at input in front of it, and basically remove all this. And of course, I don't land on the right one. I will refresh, and it's still working. That's the component using the resolver. I remove codes, just added input binding at input, and it's done. Less code to write. If you write less code, you make less bugs. Easy enough. And you can do the same thing with a param map. If I take the other one, we were using this nice function, but we won't need it anymore because we can do simply at input here. But again, the input from a param map are string, so it doesn't really go nicely with my number here. But you can use just a transform function here and say, I want a number. And there is already something for you because everybody will do that, so number attribute. And basically, you just remove a lot of code, and again, it's still working. I remove code and it's keeping working. That's nice. The next item with Angular 16 is basically in the same logic. How many of you like to write ng on destroy in your components? Yeah, apparently nobody. Or maybe one. And basically, we need to write ng on destroy, and what we do in the ng on destroy, we get all our subscription and say unsubscribe, most of the time. And that's really not that fun. We repeat ourselves again. So they introduce a new token called destroy ref. And the idea behind this destroy ref is to be able to inject it and bind it to the lifecycle of a component. So when it's destroyed, you will be notified on this destroy ref, and you can do everything you need to. So basically, you could write a function to say, okay, when I'm destroyed, I can use destroy ref, pass it a subscription, and just do what I need to do. Don't repeat yourself. But we will see we can go even further than that, thanks to React.js. So if I take one of my components here, I want to just initialize a list of dinosaur. So what I will do is call my dino service, say I want a list, I want to subscribe on it, and what we'll do, I will initialize my field. And previously, what you would need to do is to say, I want to get my subscription at some point, not in the init, but in the destroy. I will do the subscription dot unsubscribe. And basically, you do that a lot when you want to clean it up. But because React.js and Angular are so tightly coupled in a way, you can now remove all that. Just add a simple pipe in your observable here and say take until destroyed and provide the destroy ref you inject in your component, and it's handled for you. You don't need to write ng on destroyed anymore for this. So again, write less, do more. And now we're gonna land on maybe the new feature that I think made the most noise when it was announced. It's Signal. How many of you knows about Signal? Okay, good. There's a lot of you who will learn something then. So, what is a signal? A simple way to see a signal is to see it as a box. And in this box, you're gonna put something, a value. Here, a dinosaur. So you put it in your box, and basically what it looks like in your code is you define a new type signal of type dinosaur, and I provide the value for it. Until here, it's just a wrapper. Doesn't look that nice. So at some point, you will want to get back this dinosaur. So you will call dino and use parentheses. So basically, you can see the parentheses as I'm opening the box. So you open the box, you get the dinosaur. Cool. That's a wrapper. Still no new feature there. There is something more. And this thing is just when you open the box, you have something to say, the guy opened the box. So next time I'm changing the content of the box, I will notify him. But just next time. So it's not a subscription where you get all the news, or basically it's not like your beautiful subscription to Spotify or something, or it's automatically renewed or something. Here, every time you say, okay, I want the data, it will say, okay, next time I give it to you, but if you don't tell me you still need it after that, I won't bother you with that. It's nice, but it's already a danger, also in danger, and I will show you why. So we'll go through the code and try to go back here and make a little search on my dinosaur. For right now, I can type anything, there is no filter, so that's not that nice. So if I go in my list, I've already, in my template, put an input. So I will put a field to map it, so I will create a search term. And as you might guess, I will define it as a signal. And I will be nice with the typing, so I will type string here. And just say, okay, that's my input. Now I need to bind it to my input here. So I will simply use an ng model and use the signal, but because I want the value, I need to open the box. So I put the parentheses. And that's not signal, that's search term here. And when I change something, I want to be notified. So I can update my signal. And I get the event. You might be wondering why I'm not using the binary box, so the two-way binding here. It's because Signal is not supported right now with that. That's why I'm splitting the ng model using the square brackets and then the part with the parentheses for updating it. So I create the method, and what I will do in this method is basically to say, okay, I have my signal, so this put that search term, and I will set a new value in it. That's one way to update my signal. There is others, and we will see that. So nice, I have the binding, but what I really want is this filtered list. And to do that, I will try to use another type of signal. And it's called computed. So as the name suggests, the goal is to have a signal computed based on another signal. So in this case, apparently Copilot decided to make my life worse and easier at the same time. Yeah. And I don't need that. So that's a lot of code at once, so I will let you read through it. So what I take is, I take the dinosaur list, and I do a filter, and what I do is, I take the name of the dinosaur and check if this name includes what's in the search term signal to say, okay, if it's in there, I will display it. If not, I will filter it. I just need to change one thing. Right now, it's using something else here. So if I use my filter dinos with the parentheses again, no, if everything goes as planned, I have automatically filter here. And I can do that for everything, and it's working. So that's one way to use it. I just use the computed to trigger the other event. I'm going to show you some other use case so you can see all the feature of the signal at the moment. I have a little heart here. I would like to say, okay, I like that dinosaur, and just click on it. So I will go back in my component here, and this one. And I will create a simple signal to say, okay, I have a count of like, and it's a signal, and the value by default is 0. I will bind it here to have the little badge that say how many like went on it. So just put it here. And now when I click on it for like, I would like to do something. And what I will do, because I want to know, I need the previous value to know the next one, I will use something different than the set that we saw earlier. I will do an update. And what does the update? It provides you the previous value, and you basically can say, okay, that's a previous value, and with this previous value, I will update it with a new value. There is a third option to update that. The signal is called mutate. And basically, the idea behind that is if you have a large object and you want just to mutate a part of the object, that's the right method to do it. So normally, if I don't properly my job, I can click and I don't know if it's visible from there, but the number is increasing here. But I want to go further than that. It would be nice if I have a little notification or a little snack bar to say how many times it has been clicked every time we click on it. And to do that, we have another function called effect. And this effect will be triggered every time my signal is used. And it's updated, basically. I already do that, so I don't have to think about it. And what I can do here is call the snack bar, say open. And if I do this, and it's doing a lot of things for me here, and I think there is something, duration, yeah, 3000, and there. That's right, yes. So again, that's a lot of code at once. So just what I display a message saying, this dinosaur has been liked that many times, and I have the little dismiss action, and it will display for 3 seconds. So, yeah, it's working. You see it. The danger of this, and the danger of with signal, if for some reason I do if false here, I know that's not great, but the first time the signal is updated, it will be displayed. If I save and it's reloading, but if I click there, it's not anymore. The reason is because when I do if false, the first time it's called, you say, okay, I have the update, but you don't recall back the signal. And so you don't say, I want the next value, please. Notify me when it's done. So it might be really dangerous if you're not really attentive of that, because you might have not all the updates because you don't call the signal. Another danger, if you link signal between each other, you could easily make an infinite loop. And you might think, oh, that might be hard. Trust me, that's easy. Already done that, and basically your tab in Chrome will crash almost instantly. So be careful. Those signals are really nice and are a way forward for Angular. Because before I go there, when we talk about subscription, many people think RxJS. And apparently in Angular community, there is 50% of the person that like Angular RxJS, 50% that doesn't like that. How many doesn't like RxJS in Angular? Oh, yes, I have the right 50%. Signal are not RxJS. There are two things really different from each other. RxJS is built to do async call, async work, basically. You can orchestrate these async operations by doing for join, joining some observable. You can get the latest input from that. You can cancel those operations. That's not the case with signals. Signals are synchronous tasks. They allow you to have derived state, reactive state in your component. And of course, you can go from an observable to a signal. There is methods there, or the other way around. But they are not the same thing. There are two different things that can cohabitate and work together. Those signals open the way to one thing. For the longest time with Angular, even since AngularJS, we have ngZone or Zone.js, and what it does is the stuff that makes your page refresh when you change a value or something like that. And it works well, but that's not efficient at all. Why? Because if you have a hierarchy of components, and the first component has to change something, it will notify all the children and say, please look if you need to update. And basically, if you have a large graph, that can do some pretty nasty stuff. So one thing we tried for long is how can we remove that? And signals are really a nice thing. It could do that because you notify only the person that's interested by your update. So we would like to use signal. But to use it, the Angular team with Angular 17 will introduce new control flow. So the control flow are the if, the else, the for, the switch. And you might wonder, but we already have that. We have ngIf, we have ngFor, we have ngSwitch. Why do we need to change that? And the reason is, those directives are using ngZone deeply inside. So if we want to implement signal as a way to update things, we need to change that. And they basically thought, okay, but it means changing it deep. Do we really want to do that? Because we could maybe change the way we do that and have some benefits from that. And that's what's coming with the control flow. I will show you some syntax, and I will show you quickly how you can enable it, because since the latest release from Angular, so it's Angular 17 Next 6, you can enable it. We'll have something like this. For those who are familiar with Mustache, it looks like it. It's a lot like a templating engine. So you have @if, a condition, you have @else if, @else, and so on. So basically, you get rid of all the ngIf. One positive thing of that is remove also all the ng container you got because you need to put two directives on it. It was not working. No, you don't need anymore. You can do the same with a for. So @for. For those who remember, with ngFor we have track by. Now we have track with the new flow control, and you can directly use the field directly in it. And you have also a nice @empty if you want to display a message saying, okay, that list is empty. You can do the same thing with the switch case. Basically, that's the same logic, @switch, @case. And it will allow you to do basically what you do with all the ngIf and ngFor and so on, but in another way, and will help you in the future avoid using ngZone. There is also one that allows you to defer the display of a part of your page. And that can be really useful if SEO on your website is important. You can defer the loading of a component saying that one will take a long time, so I don't want to load it the first time my page is loading. So if you want to enable that, I will just check out from my repo, because to be honest, I don't know by heart this line, because you will put once and forget about it right now. I don't think this flag will last, but here, yeah, I will check out this. Force checkout. So basically, that's something you need to change in your TS config if you want to try it. It's this line. So you need to enable some block types, if, switch, for, I think you can enable also differ right now, so you can try it. I will leave it if you want to take a picture and you don't want to look around on the internet to find this line. But basically, that will allow you, if I take a component that I've rewritten using this, to do such a thing. Right now, my IDE doesn't understand a thing about that. So that's why I decided not to put it in the demo, because IntelliSense is really nice. And when you don't have it, it's basically writing with Notepad code, and that's the best way to do some stupid stuff and look for it for a long time. But basically, it's just if, else, and for that you put directly in your code. It's a new way. I know for most of the people used to the old syntax, it will take some time to learn, but that's it. The last thing I want to talk to you about, and I will go quick because time is running out, is signal-based component. Because we have the new control flow is coming, we can have signal-based components. So get out of NG zone. It will look like probably something like this. So like standalone, you will have the possibility to say, okay, there is, and my clicker is apparently dead, but go on. There is the signal to say, okay, I want to use signal, not NG zone. You will have some new signal types. So input is a signal, when you can say, okay, I have input. And also some models. There are new type of input coming with signal-based component. What it means is when you have a component that's where the signal is updated, it will only go where the signal is listened for. So you don't go through all the tree, you just go, oh, this one is interested by that. I will give him the update. And that's where I'm going to wrap it up. So we went through a lot of things, from Angular 14 to Angular 17 and a bit more. I know that's a lot of stuff. And for the most used case, it means we need to learn new things and change the way we work. And I know that sometimes it's hard, because we like our habits. But it's also a new way to improve the way we work, a way to go forward, because this new syntax that I just showed you, it will help you, Angular team, to go forward and do new things with that. Angular is quite evolving in the few releases we got, because since Angular 14 we got a lot of new stuff. And if you're really interested, you can go on the GitHub of Angular, and there is RFC, where the community can be part of the discussion, can give its opinion. A good example, if you look at the syntax, it's @if. Originally, it was the hash symbol and then the if, and the community was like, that's not really nice. And I think if there was even a curly brace hash, then something. And the community say, that's not nice. I know you want to do it, but that's not really nice, and they change it to @. So we can have an impact on that. And the last thing is probably, I know that some Java developer hate front-end, and I understand why. CSS is not nice. But Angular has still a bright future ahead, because it's quite evolving. It's not staying at the same place for 10 releases. It's trying to change, to evolve, and that's really a good thing. We cannot complain when technology is keeping evolving, because otherwise, if it doesn't do that, we're still doing COBOL, and I don't want to do COBOL personally. Last thing, thank you for being here, and if you want the slides and the code, you can just scan the QR or follow the link there. There is a GitHub repo, and there is the link to the slides. Thank you for your attention.